Okay, so question number 31, 32 and 33. If any student have doubts, then you can see cos x square. This you can solve like previous one, the one which we have done in the last class, like question number 21 and 21 and 22. Okay, you can do in that way also. You have to show the continuous function. This function is continuous, you have to show that. Okay, so that you can show for all points, right? For all points you can show by taking x equal to c minus h, then for right hand limit c plus h. You just have to use identity here. Okay, so anyway, you can do that one. Next is, see, there is alternate way also, which is very easy here. Now what is that? This function which is defined here, fx equal to cos of x square. Okay, this function which is defined here, this I can write in composition form. You have done, right? Composition of function g of h, like this composition function. So this function is actually nothing but composition of two functions. See how? If I take one function to be suppose gx is suppose cos of x, and h of x I will take suppose x square. Okay, so see, this fx is composition of these two functions. How? You can see here, g of h, if you find out composition function, I hope you remember. Why it will be easy, you will understand now. This is much more easy to solve. Okay, otherwise you can go for this one also, but this will be little lengthy. That's it. Okay, so g of hx, what it will be? G hx, right? Now we used to solve g hx is what? X square, right? Now g of x square. Now g of, when here it was bracket, in a bracket, when it was x, your function is cos x. Now in place of bracket, what is there? X square. So if it is x square, here what it will be? Cos of x square. Can you see? Cos of x square. G of hx is nothing but cos of x square. So can I say this and this same? So this fx is nothing, composition of two function, I can say. So why I'm saying that this will be much easy now. Now if you show that this is composition of two function, then you seem simple. You just show this is what? Continuous function. And this is obviously continuous, right? Polynomial. This is continuous, this is continuous. So I have given, remember in the first class of your continuity, I have given you one note. There I have given that addition of any continuous function will always be continuous. Suppose fx is continuous, gx is continuous, then its addition also will be continuous. Its subtraction also will be continuous. Then its composition also will be continuous. I said, remember? So composition of two continuous function is always continuous. So what you can do here is, you just show cos x continuous, which you have already done, right, in question number 22. And 21 also same, mixed we have done right there. Anyway, so this you show continuous by taking x minus h. This will be much more simple to solve, right, compared to this one, because in this case when you take c minus h, then again you have to think for identity, because cos square c minus h, you have to use identity. Simply you cannot put limit formula there, because cos square, see in the previous one, like for example in 21, what we have done, sine x was there, right? So we have put sine c minus h, then sine cos c minus h, like this we have put, right? Now this simple identity you have, directly simple identity you have, but this one you have to think cos square c minus h. What identity you will use? Like cos of twice x of sine twice x, like that you have to think for the identity and you have to use it. Okay, then that will become little lengthy, but in this case cos x you already done, right? In place of this one, you put left hand limit c minus h and c plus h, and try to show that this is continuous function. You can easily show that, and this so it's very easy. Left hand limit, right hand limit, f of whatever c you will take, same thing will come out for this one, because this is a polynomial. I told you polynomial is always continuous, right? So this is continuous, this is continuous, so their composition also will be continuous. Okay, G is continuous, F is continuous, H is continuous. So G of H also will be continuous composition. Okay, so you don't have to solve this one separately, directly do this one and this one, show continuous, continuous, and then say that composition of this two function is also continuous. So how you will write down this one basically? So if you want to start up, you can start like this: given fx is equal to cos of x square, cos of x square, like this, right? Let, you can write gx is equal to cos x and hx is equal to x square. Then you can write, then g of hx is equal to, you solve it and show that it is cos x square. Okay, now what you do, now g of x equal to cos x. Let means I'm going to show this function continuous first, then discontinuous. Now gx is equal to this one, right? Let c be any real number. C be, like question number 20 now. C be any real number. Then put x equal to c minus h. For left hand limit we are doing, okay? Or you can write down here, for left hand limit puts x equal to c minus h. Exactly same like 21, sorry, yeah. Then as x tends to c, h tends to 0. From there you start left hand limit, h tends to 0, cos c minus h. In place of x, just put c minus h in place of x. Okay, gx will be function here, right? Gx function means what? Cos c minus h. Okay, after that you solve, same identity you use it, and then put h 0 and then solve. Okay, you will get cos c answer here. So for right hand limit also find out, you will find cos c there also. For fc, you know it will be cos c only, right? Gc, I mean, not fc. Gc means what? C put in place of x, you will get cos c. So all will be same, so this is continuous. Show it. Next you show x square also exactly same. Okay, hx equal to this, you show this too. You don't have to let anything, right? Directly you can show. Left hand limit you show x tends to c, you don't have to take h and all here, because I told you, right, x square, it will be much more easy to solve in tabular form, so you don't need to go for this method. It's c minus h. So x square, put c directly, c square you will get. Right hand limit find out, right hand limit also you will get c square, fc also you will get c square. So here also all same, so both are continuous. So you can write, since gx, last line you can write like this: since gx and hx are continuous, therefore we know composition of continuous function is continuous. Therefore g of hx or f of x, same, right? F of x and g of x is continuous function. Okay, or f you can write g of h and f is a continuous function. Okay, so in this way you can do number 32 and 33 exactly. Okay, same, take composition, like for example number 33, I will just show you. Number 32, so what you will take in number 32? This is also composition, this is your fx, right? Fx is nothing but g of hx. Now what you will take? Gx. Gx you take cos x, and what you will take? Hx. Take mod of x, right? Modulus is there. So how you will solve this? H of x, g of hx is what? Modulus of x, right? Now see, g of x, you got cos x, so whatever is there inside bracket, here it should used to be, right? No, I think I have taken reverse, right? If I take mod x here, then in place of x, this one means this also in place of this will come out cos mod x. No, this you cannot take, right? Yes, I have to take here cos x. If I take here cos x and here mod x, then I think I will get it, right? Okay, let's see. G hx, if I take cos x, hx is cos x, right? So let me write cos x. Yes, I will get it. G of x is equal to what? Mod of x. So inside bracket whatever is there, it is inside mod. So inside bracket whatever is there, inside mod it will be. Can you see? Cos of x. G x mod of x. Now you will get. Okay. So here gx you take mod x and hx you take cos x. In this case also same, right? This is polynomial. This so obviously will be continuous, right? Graph of this one, you know, we have done already. You have to redefine this one, obviously, right? Less than 0 you take one graph, and greater than 0 and equal to 0 you take. Very simple. And this one you know how to prove continuous. So since both are continuous, so composition of these two function also will be continuous. Okay. And the last 33, what is the function? Fx equal to sine of mod x. This so obviously just now we have done mistake, right? And we got this kind of function, so you can take here that one. G of x is equal to, you can take cos x, and h of x you can take mod of x. So here you will get g of hx is equal to g hx. G of hx is what? Mod of x. So g of x inside bracket x. So it was cos of x. Cos of inside bracket what is there? Sorry, sine of. I have defined sine, right? This will be sine, sorry, not cos. Sine of mod x. So same. Okay. So you show this continuous. Then composition, you can see it will be this one only. Composition also will be continuous. So this you know already how to show continuous, and this also you know how to show continuous. So both show continuous, and then composition also say it is continuous. Okay. So here I end up 5.1, which was a little complicated also, right? And after this we will start differentiability, which we have done in class 11 also, right? Basic and principle of differentiation also we have done there. I have explained you everything there, right? Now we will start in the next class differentiability.